This video will be about the squeeze theorem. So when you're working with the squeeze theorem, the general idea is that you have a function you want to know about, and who knows what it's doing all sorts of random things. And then you have two other functions, one above it, and it doesn't have to always be above it, but it's always going to be above it at the point you're looking at. So let's say we're looking at 0, and one below it. And the goal is that eventually they would get close enough together that you could tell exactly what was going on here, even if you couldn't tell by the graph itself. And therefore you could find the limit there. So one of the most useful functions when you're actually doing problems will be a trig function, because a trig function is already limited, at least sine and cosine are. So sine starts at 0. Try that again. It goes up to 1, back down to 0, down to -1, and it just keeps going like this in a wave. So it never goes above 1 or below -1. It's already limited. So is cosine. Cosine starts at 1, goes to 0, down to -1, and back up. But again, it's limited. It's always between this 1 and -1. So you can make the statement that sine of x is always going to be less than 1 or bigger than -1. And same thing with cosine. It's always going to be less than 1 or bigger than -1. Those are always true. Something you'll also see come up is when you have sine squared or cosine squared. So sine squared x is going to still start at 0, still go up to 1, back down to 0, but then it bounces back up here. The squared makes it repeat, not as the wave before, but just as a whole bunch of mountain-looking things. So if it's sine squared or cosine squared, instead you're going to be limited from 0 to 1. You're never going to get bigger than 1, never go above it, never going to be smaller than 0. And these are for the basic trig functions. You can change the amplitude if there's a number in front. If this was 5 sine squared x, then we'd be limited from 0 to 5. Or if it was just 5 sine x, -5 to 5. But all the problems on the assignment are between 0 and 1 or between -1 and 1. Okay, so let's take a look at an example now of what are we going to do when we actually are applying the squeeze theorem. So let's say we want to find the limit as x approaches 0 of x cubed times cosine of pi x. So notice there's no number in front of cosine of pi x. That's not going to affect your amplitude. Like I said, in general, we're going to be just focusing on the -1 to 1 or the 0 to 1. So from this, we do have two parts to this function. We have the x to the third here, the cubic part, and the cosine pi x, the trig part. So you're going to focus on this trig part. You're going to say, well, I know this cosine pi x is limited. It's limited. It's always less than 1, always bigger than -1. So since that's been limited, now we have something we're already kind of squeezing between. We need to take it a little bit further. So now we need it to look like the function we're trying to get. So we need this x cubed to be put in to this limiting part. So cosine pi x, if I'm going to put x cubed in, I would have to times by x cubed. Well, just like an equation, what you do to one side, you have to do to the other. And in this case, there's 3 sides. There's to the left of this inequality sign, middle and between the inequality signs, and to the right of the inequality sign. So what you're going to have to do is to multiply this x cubed on all 3 of the sides. So that will give you negative x cubed less than x cubed times cosine of pi x less than x cubed. Now we do have to be a little particular. It's not going to affect really the overall problem, but technically we do need a absolute value sign around this x cubed and around this x cubed. The 1 is always positive up here, so this has to always be positive. If it were squared, x squared makes numbers positive. So we wouldn't need the absolute value bars for x squared. But x cubed, you know, if you have -1, -1 times -1 times -1, still negative. So we need the absolute value bars here. And then this 1 is always negative. So if we put the negative sign there, we need to make sure the x cubed itself is always positive so that this side always remains negative. Ultimately, it's not going to really affect how you do the problem, but technically they should be there. So now we have it closer to what we wanted. We have our x cubed cosine pi x. Now we need to put in the limit. So we're going to put the limit in front of everything. Again, what you do to one thing, you have to do to all three sides. So all of these are now going to have the limit as x approaches 0, negative absolute value x cubed, limit as x approaches 0, x cubed times cosine pi x, limit as x approaches 0, absolute value of cosine or of x cubed. So now the middle matches, and we want to actually apply the limit of this left side and this right side. So if we apply the limit on the left, we're just going to plug in 0. Absolute value of 0 to the third. Middle is going to stay the same. Our goal is to use the squeeze theorem to find this limit. So we're okay with that just staying like it is. Plug in 0 again. For this limit, we can just plug in 0 to get 0 cubed. So now over here, you can't have a negative 0. 0 cubed is 0. Absolute value of 0 is 0. Negative 0, still just 0. All of that becomes 0. We have our middle still the same. And 0 cubed, absolute value, still 0. So this has now been squeezed. It's supposed to be bigger than 0 and smaller than 0. Well, that means, and I guess I really should have been putting less than or equal to, because it won't make sense if we don't put the equal to. So that means if it has to be bigger than or equal to 0 and less than or equal to 0, the only thing this middle thing could equal would be 0. The left and the right match. So you're going to do the same process no matter what's with your trig function. Most of these problems will include a trig function because they're already limited. You already know nothing can be bigger or smaller. No, nothing can be bigger than the 1. Nothing can be smaller than the -1. It's got to be in between those two. So that's why most of these problems include trig functions. So even if they give you one with a radical, with a square root, you would go through and you'd do that same process. You know sine is between 1 and -1. We'd want to put in this radical. Now we know all radicals come out positive, so this time we don't need an absolute value bar. Okay, so we put our square root in, so now this middle looks like our function here. Then we have to put the limit for each of these. -1 times this would just be negative square root of x to the 5th plus x. This is going to stay the same. +1 times this is just, oh, I need the limit in front though. And I guess technically the limit is now here as well. But that function's still the same. And then you're going to plug in for the left side, plug in to find the limit. Now all of this still the same. Plug in to find the limit. And 0 to the 5th plus 0, square root, all that's still 0. I keep forgetting that less than or equal to symbol. Sorry, the bar should be underneath. So that squeezes this middle part, the limit as x approaches 0 of this function. That squeezes it to mean that this has to equal 0. So same exact idea as the last problem, even though there is a different function in front. So two variations. They could have an exponential function, so an e function. That just makes it slightly different. Square root of x squared plus x, e to the sine squared 2 pi x. So two things, I guess, that are different. We have the exponential function here, and we have squared. So this time when we take our trig function, sine squared of 2 pi x, we are limited between 1 and 0 instead of 1 and -1. We saw how that squared made it just a whole bunch of mountains, basically. Okay, so what's different about this one is to get this exponential function in, we are going to take this e and have e raised to each of those. When you put the e in, it's actually these that are becoming exponents. 0 is now an exponent, sine squared 2 pi x is an exponent, 1 is an exponent. So e to the 0 is 1, e to the sine squared 2 pi x is going to stay that way. E to the 1 is also just going to remain e. Or you could write e to the 1, but you don't have to write that exponent in. But then the rest of the process is the same. You're going to put the square root piece in, you're going to put the limit piece in. So it'd become limit as x approaches 0 of the square root of x squared plus x times 1. Limit as x approaches 0, square root of x squared plus x times the e squared sine 2 pi x, and limit as x approaches 0, square root of x squared plus x times e. And still, and not every single problem is going to be squeezed to 0. It's just one of the easier ones to do a squeeze theorem problem with. So a lot of your answers are going to be squeezed to 0, but be careful because not all of them will. Because when you plug in 0 here, 0 squared plus 0 gives you 0. Square root of 0 is 0, and 0 times 1, still 0. Limit as x approaches 0 of this big function. Then on the other side, you're going to plug in 0. So we have square root of 0 squared plus 0 times e. Well, still, this whole thing becomes 0, and 0 times e is still 0. So this whole function gets squeezed between 0 and 0. So this limit is equal to 0. This whole limit equals 0 now. So then the last type of problem they will give you is they're not even going to tell you what f of x equals. They're going to give you a limiting. Instead of sticking to that trig function where it's between -1 and 1 or 0 and 1, they're going to give you an inequality. They're going to say -4 or whatever number here, less than or equal to some function that we don't know, less than or equal to, and in this case, they're giving a polynomial function. So that's true. By saying if, it's saying if this is true, then find the limit as x approaches 1 of f of x. Well, since they didn't tell us a specific function, we don't have to make anything match, but we can put this limit in front of everything. So we have limit as x approaches 1 of -4 less than or equal to limit as x approaches 1 of f of x less than or equal to limit as x approaches 1 of x cubed minus 5x. The limit of a constant is just that, constant. There's nowhere to plug in the 1. Graphically, though, it makes sense. The number -4 as a graph is just the line here down at -4. So anywhere as you approach from the left or the right, trying to do x equals 1 as you approach from the left or from the right, still going to stay at -4. So limit is -4. Less than or equal to limit as x approaches 1 of whatever function. We don't know what the function is. This one we're going to plug in 1. We have 1 cubed minus 5 times 1. And I bet you can tell what number that's going to reduce down to, because we're trying to have the left side and the right side match so that this inner function gets squeezed between those two things. 1 cubed is 1, 5 times 1 is 5, 1 minus 5 is that -4. So this whole middle limit equals -4. If you've got to be less than or equal to -4 and greater than or equal to -4, that squeezes you down to our only option is -4. It's the only thing that could make sense. So hopefully that helps you with your squeeze theorem. Please let me know if you have any remaining questions.